All right, this is page 2 of the integral summary packet number 1. Problem 4 says a particle is traveling along the x-axis. Its velocity at time t is given below. At time 0, its position is 2 feet. So that's given right here. X of 0 is equal to 2 feet to the left of the origin. So that tells us x of 0 is equal to -2. So this is a velocity. It says the velocity with respect to time is given below. Okay. So part A says find the change in position, which is the area under the velocity curve, from 0 to 9 seconds. Part of what you should be doing in this packet as you're kind of studying and prepping for a chapter 4 test and just for calculus in general, it's a lot about studying the question, like when the question asks this, what am I supposed to do? So change in position should always trigger in your mind area underneath the derivative. So from 0 to 9, so let's see, 9 is here. So we have, let's see, this is going to be, I'm going to do a trapezoid, a triangle, here's a trapezoid, and a triangle. So first trapezoid, excuse me, is 1/2 times this height here between the parallel bases. The height is 2 times the sum of the bases, which are 3 and 4. Half of 2 is 1. 3 plus 4 is 7. This area is positive, so it's 1/2. Base is 2. Height is 4. Half of 2 is 1, so this area is 4. Here is a trapezoid, so here are the parallel bases. The height here, write this in, it's negative area, so -1/2. The height is 2 units, and the sum of the bases would be 4, right? 1, 2, 3, 4 plus 2. This is -1 times 6, so this whole thing is -6. And final area is positive 1/2, base of 1, height of 5. So that's going to be 5/2. Okay, so find the change in position from 0 to 9. So this is basically telling me, what is x of 9 minus x of 0? So I don't have a formula for x, but I can say, okay, that's just going to be 7 plus 4 is 11 minus 6 plus 5/2. So this is 5 or 10/2 plus 5/2. So I'm getting 15/2. And I always want to label everything. We are measuring distance in feet. So there's a change of 15/2 or 7.5 feet for your change in position. And remember, all that means is the particle at 9 seconds is 7.5 feet to the right of where it started. At what position will the particle be at 9 seconds? So I always like to take this back to fundamental theorem, even though I'm not actually integrating. So what should I be doing? I should be starting at the position at 0, adding the change in position from 0 to 9 of, I almost wrote x of t, of v of t dt, and that should land me at x of 9. It's a good idea to always set this up, even if you don't have an equation to integrate, because usually on free response, you'll get a point for the fundamental theorem of calculus. So just showing that you understand this is what you're doing is helpful. So x of 0 is -2. We just said the change in position from 0 to 9 was 15/2, so we don't have to show that math again. That's equal to x of 9. So I'm just going to bring this over here so it's not scrunched. So this is -4/2 plus 15/2 is 11/2. And again, I'm going to label that in feet, or 5.5. Find the total distance traveled from 0 to 9 seconds. So remember, the change in position takes into account going left and right here, positives and negatives. Total distance would just be, we're basically just saying the absolute value between x of 9 and x of 0. So total distance would just be 11 plus 6. Doesn't matter that that was negative. Plus, what was that one? 5/2. So the total distance here, 17 plus 5/2. So 34/2 plus 5/2 is 39/2 feet. So that's the total distance traveled. What is that? 19.5. So 19 and a half feet total traveled. Change in position just tells you how far are you from where you started. At what time is the particle furthest to the left? So let's see. This particle begins at -2. So x of 0 is equal to -2. And let's just mark off the positions here. So then the particle moves to the right, change of 11 feet. So that's at 1, 2, 3, 4. So x of 4 is equal to -2 plus 11. So it's sitting at 9 feet. And then what happens? Then we decrease or we move left 6 feet. That's happening at 8 seconds. So x of 8. So subtract 6 feet. You've got 9 minus 6. Now you're at 3 feet. And then ending at x of 9, the particle increases again by 2.5 or 5 over 2. So 3 plus 5 over 2. 6 over 2 plus 5 over 2 is 11 over 2 feet. So did I have to do all that work necessarily? No, but it's nice to know to answer some of these follow-up questions. So, okay, which one is farthest to the left? I basically just did a little bit of extreme value theorem, found the endpoints and found the changes in between. So it's right here. It's at -2 feet. So at what time? At t equals 0, particle is furthest left. Is it furthest or farthest? I always go back to this. I asked, I think, Mrs. Trujillo one time. Like I was like, is it? And I, of course, can't remember the rule. I'm just going to go with furthest. That's what's typed out. At what time is the particle furthest to the right? So, all right, I already figured that out. So what is our largest positive number? 9 feet, right? Because this one's 5.5. So that would be at t equals 4, furthest right. Okay. What is the acceleration of the particle at 3 seconds? So, okay, what is acceleration again? Acceleration at 3 is equal to v prime of 3. And we don't have an equation for v, but remember, this just means what is the slope of v of t at t equals 3 seconds. So take a look at your graph for t. Find 3 seconds. 3 seconds is right here. So what is the slope of this line? We are decreasing 4. Excuse me. Rise over run is a decrease of 4 over 2. So the slope is -4 over 2, which would be -2. And what's the label on that? We're traveling in feet per second. Oh, feet per second squared. Sorry, acceleration. Feet per second per second. All right. That finishes this page. We're going to do 1 page per video, so I will stop there.